of the generating unit has decided for each of our the settling time horizon, then the dispatch of this complete process is to be done by the economic dispatch problem. Now, before starting, what is the objective function in the unit commitment problem? So the main equation first is the this one equation is the objective function, where FIPIT is the cost of the thermal generators, and UIT is the status, binary status. When the unit is on, the status is 1, and when the unit is off, the status is 0. And here SUC is the total startup cost, and SDC is the shutdown cost. Now, when we consider the convex fuel cost function, the cost characteristic curve is this one. And when we consider the highly nonlinear cost characteristic, considering the wall point loading, the thermal generator, then this one is the cost characteristic curve. Now, this startup cost as a function of this one. HC is the hot startup cost, and this CSC is the cold startup cost. And this TI down and TI and TI up. The TI down is responsible for the how the thermal generator unit has to be off, for how much time period it is off, and for TI up, it is how much time period it is on, up. So this is the basic objective function, and these are the constraints which are imposed on the cost-based unit commitment problem. Now, the first one is simple, the power balance constraint, and second one, the spinning reserve, how much how it kept for the in the reserve for allocated to the total demand, and these are the generation limits. Now, generation limit in the range of minimum to maximum, and this the important constraint in the unit commitment problem, that the unit is how much time period it is off and how much time period it is on. And then the for the practical power system, to make the this unit commitment problem for practical, we have used considered the ramp rate limit, that is UR is the ramp up, and DRI is responsible for the ramp down. So again, these are the power flow constraint. This is the power flow. Then there is the generator limits, and then again this is a voltage limit, and then line and transformer tap settings. So behind the basic, I have used the methodology. Actually, I have adopted the GAMS environment, and the methodology used as in this paper is the GAMS DECOP solver. Now, the DECOP solver means it stands for the discrete and continuation optimization problem. So the basic flow in this GAMS software is, first we define the number of sets. Now, suppose in this problem there are thermal generators, and there are the 24-hour time settling time horizon demand. So the set has to be defined as the number of generators cross number of total time intervals. So this is defined as the set. Then we have load the data in the GAMS, that the data of thermal generators and the total load demand. Then we have defined the variables in GAMS environment. Then after defining the variables, we have just done the problem formulation of all the equations, objective function as well as the constraint, in the form of algebraic equations. Then after doing all these things, then we define what kind of nature is actually the problem is. Suppose the problem is of linear type, then we consider the simplex solver. Then again, if it is not very highly non-linear, then when use the Baron or Cumming or the GAMS DECOP solver. And now in this paper, I have used the DECOP solver. The basic thing is that in this, why I have chosen the DECOP solver. The importance of this is that the DECOP solver has been working on the outer approximation algorithm. So that's why I have used this one. Now, the right hand side is the basic flow chart, that how the unit commitment problem is modeled in GAMS and how the complete GAMS process flow. So these are the result and discussion part. Now, this solver has been applied on the IEEE 30 bus system. To find the efficacy of this, I have taken the data from the reference number 7, 8, 9, and 10. So these are some of the reputed journals paper, and the voltage angle limits has been considered as minus 45 to plus 45 degree, and the voltage values are taken as a 10% tolerance from the minimum and upper bound. So in IEEE 30 bus system, this is the important thing which I have done for P load calculation. Now, how the in IEEE 30 bus system, how load is divided, because load is of 24 hours, and how this load is divided into each and every bus. For this, we have made this calculation. Now, suppose if in 24-hour time period there is a one maximum load, so for the first hour calculation, suppose in first hour there is 166 megawatt of load, and the maximum load at the 24 hour is 283.4 megawatt, that is the bus power, bus 5. So the calculation is made like this: 166 divided by 283.4 into 0. Now 0 stand for that at bus number 1 the p load is 0 u per unit. So this is the calculation for each. Likewise, you had made calculation for each and every bus. Likewise, this is for active power, and you have also done the calculation for the reactive power also, reactive load also. So after this, these are the results for IEEE 30 bus system. In this, there are 6 generating units. Now, these are the status of these are the status of the 6 thermal generating units, and these are the cost. Now, after applying this, the total operating cost is found to be 12970.50. Now, this is the total operating cost by Decop solver, and this is the total loss 140.81 megawatt. Now, the assessment of total operating cost will be previous best techniques. Now, these are some previous best techniques, that is the dynamic programming, branch and bound, all these. Now, we can clearly examine here that the Decop solver gives the better results in terms of the operating cost. Now, one interesting observation in this table is that the execution time taken by this solver is slightly more compared to DP and ACS Arnold Colori method. The main reason behind this is that whenever you can model this formulation in MATLAB, now in MATLAB we can design each and every function separately, and we can randomly we can parallelly we can run it. But in GAMS we have model each and every equation in one file, and after completing all the process of constant and objective function value, it will give the results. So that will take a very long computational time for each and every for each and every line running. So that's why the total execution time also can be increases in this GAMS Decop math solver. So the basic conclusion in this paper is that effectiveness of this software has been successfully tested in this paper on the IEEE 30 bus system. Now, this paper make a fresh attempt to test the unit commitment problem. Simply, I have considered a unit cost-based unit commitment problem. In the future, you can also be considered the profit-based unit commitment problem, or maybe considered some renewable energy sources in this. Now, the main advantage of this software is that you cannot model the which type of solver we actually use. We can only identify the nature of the problem, and according to it, we can use the solver. But the main difficulty here is that you have to model in this only in the form of algebraic equation, which is very easy in other software like MATLAB. Now, MATLAB is a high-level language, but where you can easily model each and every equation, like if you can model for loop or else or other loop, you can easily type if for. But in GAMS, it is not the facility. We have to model for this is to using some algebraic. You can done this in the form of some algebraic modifications. Now, these are the some of the references. Now, I have taken the 7, 9, and 10. These are references for to consider my work, and I have compared the results. And GAMS Decop solver gives the better results. So this is all from my side, sir.
Okay, Vinit.
Yes, sir.
Can you do you have any diagram for this IEEE 30 bus system?
No, actually, I have not having because the limitation is only of 10 slides. No, I does not kept the diagram for this, no, sir. But
Okay.
IEEE 30 bus system has 6 generators, six thermal generators, sir.
How many generating units you considered?
Sir, six. IEEE 30 bus system has 6. Yes, sir. The results is only, yes, sir.
Yeah, if you are having a 6 generating units and we want to operate our system in economic load dispatch.
Yes, sir.
But at the same time, we are implementing unit commitment.
Yes, sir.
Can you differentiate the two?
Yes, sir. Actually, in economic dispatch, there is certain amount of generating units, and we have to satisfy the total demand. Okay, sir. But in this unit commitment problem, there is a certain amount of generators. We have to satisfy the demand. But how, which is the most efficient unit, and how much time period will be run? Suppose there are 6 generating units. Now, in this 6 generating unit, which is the most efficient unit? And for how much time period that unit will be run so that we use the better optimum operating cost. So it will be defined by the unit commitment process. For how much time period that unit will be run, means that how much time period it will be on for and how much time period it will be off. So this is the basic advantage, and actually economic dispatch is sub problem of unit commitment problem, sir.
How will you decide the startup time cost and your shutdown cost? How will you
Actually that
decide?
is a actually
When
sir,
load,
this is the reference.
particularly when load is fluctuating at every moment of time.
Yeah, sir. Actually, na the startup cost and shutdown cost of thermal generators, as given in this paper, that is the paper number 7, sir. So that value I have taken only from there, the SUC and STC cost, and this is the problem formulation, sir. In equation number this, now HSC data is given and CSC data is given. Now HSC is the whole hot startup cost, and CSC is the cold startup cost, sir. And these parameters are depend on this one, ki how for how much time period that unit is off.
Yeah,
Okay, sir.
that is okay. But my question is, how will you decide that cost? How will you calculate that cost? Is there any mathematical model to calculate that cost?
No,
Because
no,
when
sir.
you're going to switch on and off your generating, particularly thermal unit, and sometimes operating the thermal unit and taking it shut down, it will more cost while we are going to operate again operating the same thing.
Yeah, sir. Actually, I considered your point, sir. But actually, I have considered these values SUC and SGC only from the base paper. That I have already mentioned it, na, sir. Actually, in this base paper, they actually considered the each and suppose there are 6 thermal generating units, and they are considered this STC value as a fixed value for 6 these thermal generators, sir. So I have considered that
Okay, you have
those.
considered whatever they people have
Yeah,
mentioned over there.
yeah, yeah, sir.
Based
Yes.
upon that, you perform your calculation.
Yeah, sir. Yeah, that's why I compare the results from only those techniques which I considered though the fixed value of SDC, sir.
Okay. ठीक है. Yeah, Gagan ma'am.
Any questions? Any questions? Any more questions? Thank you, Vineet sir.
Okay,
Thank you,
okay,
Pawan
ma'am.
sir.
Thank you.
Thank you, Pradeep sir.
It's fine at my end. Please proceed, ma'am.
Okay, sir.
Okay, thank you, ma'am.
Next paper, I would like to call paper index number 26. 28. Ashi Gupta, Aditi Dhar, Anshi Jindal, Bhavna Shishodia, and Himani Garg. The paper title is Remote Monitoring Real-Time Air Pollution, IoT Cloud-Based. Anyone present?
Hello, ma'am.
Hello?
Can I present?
Yes, ma'am. Yes, ma'am.
Okay. Wait.
Mr. Bhavana Sodia, we do not have your PPT with us. I think, have you sent to someone?
Yes, sir. I have uploaded on FITE-2020 @abs.ac.in.
Okay, then we'll try to receive from there. Please proceed.
Okay, sir. Okay, sir. Is my screen visible?
Yes, ma'am, it's visible.
Okay, ma'am. Okay. Now I start. So here my title of my paper is Remote Monitoring Real-Time Air Pollution, IoT Cloud-Based. I am Bhavna Shishodia from ABS Engineering College, and I am from Electronics and Communication Department. So as we all know, in today's time, air pollution is increasing day by day, and quality of air is decreasing day by day. It is becoming a matter of concern for everyone, as it can cause lungs, aging of lungs, asthma, and cancer, and many big problems. So our idea is to deploy the different sensors on different locations, and we can use that for our cloud or for further investigation or further methodology or further things to control that. So these are our things that we learned from different papers. First of all, first thing is that we have to install quality sensors in traffic area, industrial area. जैसे इंडस्ट्रियल एरियाज में अगर हमने अपना सेंसर वो इंस्टॉल किया और अगर उस और हम वहां से अपना जो एयर क्वालिटी इंडेक्स है हम उसको मेजर करेंगे और उस डेटा को कंटिन्यूसली रियल टाइम डेटा को क्लाउड पे स्टोर करते रहेंगे थ्रू माइक्रो कंट्रोलर और IoT गेटवे. From microcontroller, we control all the sensors, and through IoT gateway, we send that data to cloud, real time data, and we can analyze that data. And after analyzing that, we show that data on an app, which can which everyone can access and get the real time view of air quality in our areas. And we can employ these sensors everywhere, like industrial areas, traffic, residential areas, and many more. And cloud is a good option for us as it can store data and we can use that data for further use. And so we all know that gases like CO2, SO2 are very dangerous for human beings. So we measure these gases and we can tell them the exact values through an app which everyone can check so that they can change their route or they can apply any application to the government so that they can tell the industries to reduce their pollution level or anything that they can do to reduce air pollution. It will help many people, and our result is that different sensors will deployed at different locations and air quality is given and it is available for common man on their smartphone. Then they can easily access at any time, anywhere. This is our conclusion. We can also through this we can also employ an LCD which at roads, at streets, at corners where everyone, those who don't have smartphones, can see the air quality there and choose their routes or apply an application for government for reducing that air pollution just by giving the industries notice to decrease their pollution or otherwise shut them or उनको वहां से मतलब displace them from any other display them for any other place. So these are our references. In these our references are totally based on how can we employ sensors and how can we send data through Wi-Fi and totally IoT based project so that everyone can access the sensors, everyone can access the data and knows about the situation. Thank you.
Bhavna, is the presentation over?
Yes, ma'am.
Okay. Any questions from session chair and co-chair?
Yeah, Bhavna.
Yes, ma'am. Yes, sir.
You are BTech student?
Yes, ma'am.
Which year?
Fourth year.
Fourth year. Did you have this kind of project in your capstone, like you are doing your project in final semester?
Yes. Yes, sir. Yes, sir.
Do you have any hardware of that?
Sir, I'm working on final now app management. Like I have done previous projects like these, which I can handle the hardware. So now I'm learning software, like app management, front end management.
No, other than app management, do you have any hardware? Do you have any sensor? Then you simulated with your interface with your internet Modbus, and then you have some result over this laptop screen like that. Do you have any processor?
Right now, I don't have my laptop, but I don't have air pollution sensors. But I have used different type of sensors like IR or ultrasonic and these. So this is I will try first time like air pollution sensors like NO2 sensors or CO2 sensors. I'll have to simulate them, but this is my idea.
You are from electronics branch?
Yes,
Electronics
sir.
and communication?
Yes, sir.
Hmm?
Yes, sir.
Yeah. Do you know any communication protocols while you are going to interface your internet activity with your real-time system?
Sir, we can send data through GSM, as GSM is available everywhere and everyone can access that. And there is no need of
I'm
internet
not
connection.
asking how you are going to access the data. I'm asking, is there any protocols, communication protocols you have to follow?
So we can use Wi-Fi,
Okay.
sir. Through
ठीक
Wi-Fi,
है
we
भावना,
will. Okay, sir.
थोड़ा उसमें हार्डवेयर बनाओ और उसको इंटरफेस करके थोड़ा सा इसको रन करके सीखो इसको।
Simulation.
हाँ, सिमुलेशन, सिर्फ सिमुलेशन से काम नहीं चलेगा. दिस काइंड ऑफ प्रोजेक्ट यू कैन हैव सम हार्डवेयर टाइप आल्सो.
Okay, sir. Thank you.
Any more questions? Thank you, Bhavna. Thank you,
Thank
Pradeep sir. Thank you, Pawan sir. Now I would call the next paper, that is paper number 41, authored by Vandana Jha, and the title of the paper is Modeling and Simulation of H-type Multi-Level Inverter with Secondary Circuit. Vandana ma'am, are you there?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, ma'am.
Just a second.
Vandana ma'am, do you know how to operate this MST?
Yes, ma'am. Do I have to go to share tray right now?
Yeah. Yes, ma'am.
Then I'll have to go to the desktop.
Yes.
Yes, ma'am. Ma'am, is it visible? My screen?
Yes, ma'am. It's visible.
Good afternoon, everybody. I am Vandana Jha. I am from C.V. Raman Global University. My paper ID is 41, and the title of my paper is Modeling and Simulation of H-type Multi-Level Inverter with Secondary Circuit. The paper ID is 41. Tract of this paper is, this paper presents the modeling and simulation of 5-level H-type inverter configuration with secondary circuit. The implementation of 5-level H-type inverter with secondary circuit requires only 5 MOSFETs, 4 diodes and 2 capacitors, which is notably less against the devices utilized in the conventional H-bridge inverter without secondary circuit. A comparative analysis of the parameter values, fundamental voltage and total harmonic distortion of simulated load voltage waveforms of 2-level full bridge inverter, 5-level conventional H-bridge inverter and 5-level H-type inverter with secondary circuit has been accomplished. The results show the supremacy of 5-level H-type inverter over 2-level full bridge inverter and 5-level conventional H-bridge inverter. The simulation of H-type inverter with secondary circuit is achieved on MATLAB platform. This is the 5 papers which I have extracted from the references and the conclusions which are made for the literature review. The 5 papers are from the IEEE, either the transaction papers or the conference papers. Now let us go to the methodology, the modes of operation. This is the circuit diagram of a 5-level H-type inverter. Basically, we have to produce the 5 levels those 5 levels are, the first level is V in, the second level is minus V in plus V in by 2, the third level is 0, the fourth level is minus V in by 2, and the fifth level is again minus V in. So these are the 5 modes of operation. For the first mode of operation, V in, the circuit consists of 5 MOSFETs. This is the secondary circuit, and we are having 5 MOSFETs, MOSFET 1, MOSFET 2, MOSFET 3 and MOSFET 4, and in the secondary circuit we are having MOSFET 5, and we are having 4 diodes D1, D2, D3 and D4, which constitutes MOSFET 5, and 4 diodes D1, D2, D3 and D4 constitutes the secondary circuit. And in the primary circuit we are having MOSFET 1, 2, 3 and 4. Here we are having the load, which consists of R and L connected in series, and this is the V in voltage which is to be applied. So for the first mode of operation, where we have to produce voltage V in, the current flow direction is from this to this, again from here to here, from here to here, it flows from here, it goes to here, and finally this one. So across the load we are getting the voltage as V in. In case of mode 1 operation, MOSFET 1 and MOSFET 4, both of these are functional. Now for the second mode of operation, that is plus V in by 2, the direction of the current flow for plus V in by 2 is, because this is the midpoint of this total circuit, which is made by the voltage divider R1C1 and R2C2. So the direction of the current is from this, from here, again it goes from here, from this it goes to this one, from here, this, again this is the return path of the flow. So this current flow produces here across the load, across RL load, we are having the voltage which is applied is V in by 2, because this voltage is taken the positive half, this positive point is connected through the positive half of this V in, and it is connected to the negative half. So across the load we are getting the voltage as V in by plus V in by 2. Now the third mode of operation is 0. So for the 0, the current flow direction for the third mode of operation, that is 0, it is from this, again from here, and then from here. So the MOSFET 3 and MOSFET 4, both of these are functional, and across the load we are getting the voltage as 0. So this is the third mode of operation. Then for the fourth mode of operation, we are having, for the fourth mode of operation, we have to produce the voltage minus V in by 2. So for minus V in by 2, the direction of the current flow is from here, this one, this, from current flows here, again it goes like this, from D2, it flows like this, again up to this. So across this load, the voltage that we got is minus V in by 2 across the load for the fourth mode of operation. And last, for the last mode of operation, we are having minus V in, and the direction of the current flow for minus V in is like from here, again to here, and then here. Again the current flows like this, the direction of current is like this, and then from here. So across the load we are having the voltage, that is we are getting as minus V in. So 5 level of voltages, those are V in, plus V in by 2, 0, minus V in by 2, and minus V in, that we are getting from the 5 level H-type inverter with secondary circuit. And also with the secondary circuit, only 5 MOSFETs are required. However, in the conventional H-bridge circuit, 8 MOSFETs are required. So there is a great and drastic reduction in the number of MOSFET switches. So this is what is the methodology. and this is the switching arrangement for the production of 5 levels of load voltage, and for MOSFET 1 for the production of V in, again V in by 2 0 minus V in by 2, and for minus V in. Now here I have made a comparison between the conventional H-bridge inverter and H-type inverter, the fundamental voltage and the THD. The column this represents the conventional H-bridge inverter, and these values represent the H-type inverter values with secondary circuit. And as you can see, the THD in case of this is very small as compared to that of the, I have varied the frequency, and I have kept the load R at 50 ohm, and the value of the THD in case of H-type inverter with secondary circuit is very less as compared to that of the conventional H-bridge inverter. Here in this I have kept the frequency as constant, that is our 50 Hz, and I have varied the load, that is I have varied the value of R, and again the value of THD in case of H-type inverter circuit is very small as compared to that of the conventional H-bridge inverter. Now here I have made a comparison between the full bridge inverter and H-type inverter with secondary circuit. As you can see here, again I have varied the frequency, I have kept the load as constant, and again the value of the THD in case of H-type inverter with secondary circuit is small as compared to that of the full bridge inverter. And here again I have kept the load as constant, and I have varied the value of inductance. I have increased the value of inductance and I have kept the frequency as constant, and again I have made a comparison between the value of total harmonic distortion, that is THD. And here again I have kept the value of inductance as constant, and I have increased the value of resistance, and with the varying R, the value of the THD is shown. And in every case we can see, hence in the conclusion part we can say that by analyzing the results it can be concluded that the H-type inverter with secondary circuit is capable of producing 5-level load voltage by employing nearly 5 MOSFETs, 4 diodes and 2 capacitors. The second conclusion, the THD of load voltage waveform of H-type inverter with secondary circuit is always less than that of full bridge inverter, which confirms the H-type inverter supremacy over full bridge inverter. The third conclusion is the THD of load voltage waveform of H-type inverter with secondary circuit is also always less than that of the conventional H-bridge inverter, which again confirms the H-type inverter supremacy over conventional H-bridge inverter. And the last is the H-type inverter configuration with secondary circuit has lessened the complication of power circuit for low and medium power functions. And these are the references which I have used in my paper. Thank you.
Thank you, ma'am. Sir, any question at your end? Anyone?
Yeah, Vandana ma'am, you are faculty in Global University?
Yes, sir. Yes, sir. Yes, sir.
Can you show me the diagram in your actual diagram, whatever you consider in MOSFET 5 levels?
Sir, in this slide only? Sir, in this slide.
Yeah, this one.
Yes, sir.
In this case, you in your result and discussion, you have shown that you have varied the frequency. Though your input supply is DC, how you varied the frequency?
Yes, sir. My supply is right, sir, DC. But when I calculated the THD for after going to the FFT, here in the load, there was the option of changing the frequency. There I changed the frequency and I found the THD, sir.
How did you change the frequency though your supply is DC?
Yes, sir. Here the supply is DC. But sir, for the FFT analysis, when I went to the FFT analysis, there I could change the frequency, and there the values were changing, and I tabulated those values. Actually, this was the project which was the student was under me for the MTech. So that he found the tables. He gave me
my
tables
next question. Okay, Vandana madam. My next question is, you are having here R and C component.
Yes, sir. Yes, sir. I'm
How
having
did you
here R
decide
and
the
C.
value of R and C?
Yes, yes, sir.
How did you decide the value of R and C?
Sir, basically it is used for the division of voltage, this V in voltage. So I wanted to divide it into two equal parts, V in by 2 and again V in by 2. These two equal parts. So this is how I decided the value of R1 and C1. In the MATLAB Simulink, I have given a certain value and I found that the result which I was getting was fine. This is how I decided the value of R1 C1.
How did you calculate the value of R1 and C1?
Sir, I didn't use any basic calculation. I gave the value to the MATLAB Simulink diagram and I found that the results were fine because I wanted to divide
There
this
should be some analysis behind that. What value of R should be, what value of C should be, so that you can get that much voltage. Unless we are not knowing the rating of power component, how we can calculate the output?
Yes, sir. That was there. If I'll open my MATLAB and I open this simulation, I will be able to show you what was the value of R and C.
You have taken at random.
Likewise, sir. I have not taken it as random, but I have found it somewhere and I have put that value.
In that case, if you are taking at random at your choice, then how you can compare your result with the others? Unless your circuit conditions are not same.
No, sir.
Okay, this is my suggestion. You should have an knowledge of how to calculate these components, because
Okay,
when
sir.
you are going to compare your results, then it is only possible if some reference have been set.
Okay, okay, sir. Okay, sir. Okay, sir.
Okay. Okay, madam. Thank you. Pradeep sir,
Thank you, sir.
Gagan ma'am.
Thank you, sir.
No, it's fine at my end, sir. Pawan sir, it's fine.
Okay, sir. Next, we can ask the other authors. Paper ID number 32. Farah Usman and Ram Suchit Yadav. The title of the paper is Web Band Reconfigurable Antenna with Frequency, Polarization and Pattern Diversities. Farah Usman, are you present, sir?
Yes, ma'am.
Oh, okay, ma'am. Are you present, ma'am? Farah?
Yeah, I'm here.
Okay. Thank you.
Farah ma'am, are you comfortable with the how to operate the PPTs on this platform?
Yeah, just give me 5 seconds.
Okay, ma'am.
I'm sharing the window. Good afternoon, everyone. Is the screen visible?
Yes, ma'am, it is visible. You can go ahead.
Good afternoon, everyone. My name is Farah Usman, and I'll be presenting paper ID 32. The title of my paper is Wideband Reconfigurable Antenna with Frequency, Polarization, and Pattern Diversities. Reconfigurable antennas are basically antennas that are capable of modifying their frequency of operation and characteristics, that is polarization, radiation pattern, bandwidth, or any combination of one or more of these characteristics in a controlled and reversible manner. The purpose of diversifying these characteristics is solved by means of redistributing the antenna currents, which in turn results in alteration of the electromagnetic field of antenna's effective aperture. There are many techniques to achieve the purpose of reconfigurability, which includes switching as well as non-switching options. In case of non-switching actions, techniques, non-switching techniques actually include some kind of mechanical, optical, or chemical arrangement, whereas we alter the property or material of the antenna, which in turn change the permittivity or permeability of the dielectric material or the substrate. The switching options, whereas include use of some kind of switches, for example, pin diodes, varactors, optical switches, or radio frequency microelectromechanical switches for the purpose of diversifying these properties. In the proposed design, I have used 4 pin diodes to accomplish the task of altering these properties, these characteristics. The proposed design is on your screen. The antenna has an outer square patch and an inner circular patch as shown in the adjacent figure. The FR4 substrate has been used with thickness of 3.2 millimeters and permittivity of 4.4. The loss tangent in this case is 0.02. The antenna is 39 millimeters long and 36 millimeters wide. 2 pair of pin diodes have been used here. For feeding, I have used 2 diodes, D1 and D2 on the screen. These are 2 diodes for feeding. This one is D1 and this one is D2. And to connect the inner circular patch with the outer square patch, I have used again 2 different pin diodes, D3, this diode, and D4, this one. Based on the switching combination of these 4 pin diodes, D1, D2, D3, and D4, the antenna operates in 15 different modes. For example, if all the 4 diodes are switched off, the antenna operates in mode 0. For mode 1, only diode D4 has to be switched on, and the rest of the diodes D1, D2, D3 will be switched off. Similarly, all the other modes switching combinations have been mentioned here in this table. Depending on the antenna modes, the antenna offers wide band operation. A wide band operation of an antenna basically refers to a bandwidth somewhere greater than 500 megahertz. We can see the result on the screen. The wide band operation is in mode 1 for frequency 3.565 gigahertz. It offers a bandwidth of 990 megahertz. It is minus 10 dB bandwidth. In mode 4 at frequency 6.13 gigahertz, the bandwidth offered is 2160 megahertz. Similarly, in case of mode 8 at a frequency 3.52 gigahertz, the antenna offers a bandwidth of 1080 megahertz. In mode 15, the antenna exhibits wideband operation at two different resonant frequencies. 3.56, it offers 1140 megahertz of bandwidth, and for frequency 6.085 gigahertz, it is 1575 megahertz of bandwidth. Frequency diversity. In all these 16 different modes, the antenna resonates at different frequencies. In mode 0, the antenna operates at a frequency of 5.725 gigahertz, 7.35 gigahertz, and 10.15 gigahertz. Similarly, in mode 1, the antenna operates at a frequency of 3.565 gigahertz, 4.195 gigahertz, 5.815, and 7.255 gigahertz. There are other combinations. For example, in mode 13, the antenna operates at a frequency of 2.62 gigahertz, 3.61 gigahertz, 4.465 gigahertz, and 6.13 gigahertz. So for each mode, there are almost a different set of frequencies the antenna operates in. Regarding polarization and pattern diversity, it has been observed that this antenna exhibits linear polarization in mode 7 and mode 8 at 2.44 gigahertz frequency, because the axial ratio is 33 dB and 30.3 dB respectively in these two different modes. In all other modes, this antenna exhibits elliptical polarization. Regarding the pattern diversity, we can see on the screen, the main lobe direction changes its direction from plus 30 degree at mode 9 at 4.195 gigahertz to a main lobe direction of minus 30 degree in mode 4 at 6.13 gigahertz. So this particular antenna shows diversities in frequency, diversity in polarization, as well as pattern, radiation pattern. I've compared the results of this proposed design with the reference papers I've taken in terms of the size of the antenna, in terms of the operating frequency, maximum gain, which is there for this antenna, reconfigurable characteristics, and the switching elements. As we can see on the screen, the reference paper 1, which I have taken for my paper, has an antenna of size 88 millimeter by 88 millimeter by 1.6 millimeter, and the operating frequencies for that antenna is 226 gigahertz. The maximum gain that has been achieved from that antenna is 4.19 dB. The antenna was exhibiting diversity in frequency only, and it was using 4-pin diodes for switching. The paper, which has been taken as reference 2, has the antenna dimensions as 3.14 by 24 by 1.6. It was operating in two different frequencies with 2.45 gigahertz and 5.8 gigahertz. The maximum gain which was achieved with that antenna was 5.06 dB. It showed variations in frequency, resonant frequency only, with a combination of 3 diodes, pin diodes. Similarly, there are other details of reference antennas. The 3 and 4 reference papers have showed characteristic that is reconfigurable was polarization. The antenna was able to show different types of polarizations. Paper 3 was using 12 pin diodes, whereas paper 4 were using 4 pin diodes. The maximum gain in case of antenna 3 was 6.7 and in case of antenna 4 was 7 dB. The operating frequencies were 2.34 to 2.48 gigahertz for antenna 3, and antenna 4 was operating at frequencies from 2.05 gigahertz to 2.7 gigahertz. The antenna size for antenna 3 was 90 millimeter into 62.2 millimeter by 0.508, whereas antenna 4 was having dimensions as 104 by 59 by 0.76 millimeters. Antenna 5 exhibited diversity in pattern, radiation pattern of the antenna using 8 pin diodes. The maximum gain was not mentioned in the paper, and the operating frequency was 2.4 gigahertz. It was a circular patch of 90 millimeter diameter. Paper 6 operated at frequencies starting from 2.2 gigahertz to 8.4 gigahertz. It showed diversities in frequency and pattern using 2 pin diodes. The maximum gain that was achieved using that particular antenna, that is antenna 6, was 4.5 dB. The antenna dimensions were 52 by 46 by 1.6 millimeter. The proposed antenna has the dimensions of 39 millimeters by 36 millimeters by 3.2 millimeters, and it operated at frequencies starting from 2.485 gigahertz up to 9.955 gigahertz. The maximum gain which was achieved in this antenna was 6.76 dB. It showed variations in the resonant frequency, the polarization, as well as radiation pattern using 4 pin diodes. An additional advantage of this antenna was that it was able to exhibit wideband operation. The antenna was showing wideband operation in many modes at different frequencies, as I have stated earlier. So the proposed antenna, we can say, exhibits diversities in frequency of operation or resonant frequency, polarization, and radiation pattern with the help of a combination of four different pin diodes, where two diodes have been used for feeding and two diodes have been used to connect the outer square patch with the inner circular patch. It finds its applications in WLAN, which has frequency 2 to 6 gigahertz, WiMAX 2.4 and 5 gigahertz, S bands 2 to 4 gigahertz, C band 4 to 8 gigahertz, and X band 7 to 11.2 gigahertz. And current wireless communications well used for the future 5G mobile communications. Its capability to alter its polarization and pattern along with the resonant frequency makes it more useful in these above listed applications. Here is a list of references which I have used, and I've compared the proposed design with these antennas. Thank you. Any questions, please?
Thank you, ma'am. Any question, Dr. Pawan and Dr. Pradeep?
Yeah, Farhan.
Yeah.
Yeah, I have a question. What is the shape of your antenna you selected or you proposed even?
I'm showing you the antenna design. Yeah, here is this design. You can see the ground. I have used reduced ground with two stubs, and this one is the patch. The patch has an outer square patch with an inner circular patch. Between this, there is a gap wherein the substrate is there, and these two patches are connected with two diodes D3 and D4.
What is its shape you have described in your work?
Square
Whether it's
patch.
considered it is a square, hexagonal, triangular.
It's basically
what is
an
the shape
outer
you?
square patch. Outer square patch with an inner circular patch.
Outer square patch with an inner circular patch. Okay.
Yeah.
Now, in this case, you have used 4-pin diodes.
Yeah.
And one of the reference you have shown, he has used 12-pin diodes.
Yes.
Comparing these 4-pin and 12-pin diodes, reconfigurable opportunity will be less or not?
In case of my antenna, the antenna is showing reconfigurability in case of frequency, polarization, as well as pattern. But in that particular antenna, it was showing reconfigurability only in case of polarization, and it was able to give polarization, circular type of polarization, RHCP and LHCP both.
Now, if you are comparing, if their approach is different, then how you can compare your result with that particular? When the same is implemented in your case, he may produce the better result.
Actually, that particular design has been taken to produce circular polarization. Polarization is basically of three kinds in case of antenna. It is linear, it is elliptical, or it is circular. So that antenna is basically producing polarization of circular kind, and my antenna is basically producing polarization of rest of the two types, that is linear and elliptical.
This is the only difference.
This is the only difference, that this my antenna is not producing giving polarization of circular kind. If I would like to produce circular polarization, then I have to use more than 4-pin diodes.
What is the method you use to find out the optimal reconfiguration?
It was basically starting from the design. I started using the square patch, and I've checked the reflection coefficients changes with minimizing the size of the antenna and minimizing the ground of the antenna. Then I have used the introduction of stubs to increase the gain, and then I have used these 4 diodes to change the parameters characteristic, that is frequency, polarization, and pattern. I've done the simulation on HFSS version 13.
You perform the simulation only.
Yeah,
no
I told.
algorithm have been developed to find out the optimal sizing of this reconfiguration
In the
antenna.
simulation, there is an in the simulation there is a part that we have. There's a part that we can use for simulation and for to achieve the optimum value of this antenna size. It gives the option of optimizing the results, the size, the
This is the
parameters.
inbuilt features of that software.
Yeah, yeah. It is inbuilt
What is
software
that
and
software
so
you used?
it is ANSOFT HFSS, that is High Frequency Structure Simulator version 13.
Okay. Okay, madam. Gagan ma'am.
Hello, sir. Hello, ma'am. Ma'am, thank you very much. I'm just calling Shailen, sir, for paper ID 33. Shailen, sir, are you there? Shailen Visari, sir, are you there?
Thank you so much.
Thank you, ma'am.
Okay.
Naveen sir.
Yes, sir. I'm listening, sir.
Yes, sir. Sir, I have shared my video yesterday, and I requested to just play that. Is this possible?
Let them, reply on this behalf. Pradeep, sir, and Pradeep,
No
sir.
issue, no issue, no issue.
So should I play on your behalf, sir? Shailen, sir,
Yes,
you
yes,
ready
yes,
for
yes,
video?
Naveen sir. I have no issue.
Okay, sir. Sir, this is audible to all of you. Should I continue with this?
Yes.
Okay.
Navin sir, what is the issue? Navin sir?
Sir.
Hello, sir.
Yes, sir. I think is this voice is not audible to you?
Yes, you are audible, but
Sir, video is not audible. We can't see anything. Nothing is audible actually. Nothing is going on.
Okay. Just wait a moment. Now is it audible to you?
Gagan ma'am, we can start the next candidate. Meantime, he can ready his presentation on.
Yes, sir. We can go. NP sir, can you announce?
Yeah.
The next.
Yes, paper ID 53. Who is there for the paper presentation? Paper ID 53. Mr. Rajat Yadav, Anas Islam, and Aman Sharma. I think none of them is here. So let me call another one. 57, paper ID 57. So out of paper ID 57, are you there? So I'm going next then. Rishabh Chaturvedi and Rajat Yadav. Any one of you are there? Rishabh Chaturvedi, Rajat Yadav. Okay, moving ahead, Mr. Anuj Kumar or Mr. Asif Ali Sayyed and Mr. Anup Pandey from paper number 62. Is anyone present over here? Okay. I know who's Anuj Kumar, sir.
Yes, Anuj Kumar, Mr. Anuj Kumar, Dr. Asif Ali Sayyed, and Dr. Anup Pandey.
Okay, so Anuj sir, you are going to present for this paper ID?
Yes, sir, I will present.
Okay, so you can go ahead with.
So, can I share my screen?
Yes, sir, you can. Please go ahead.
Okay, 1 minute. Is my presentation visible to all?
Yes, sir, it is visible. Just make it in presentable mode only. Otherwise,
no, I also need to use one Excel, so that's why I'm not making it
okay.
in presentable mode. Okay, so first of all, a very good afternoon to all of you, and thank you FITE for giving us this opportunity to present our paper in this AICT sponsored conference. The title for our presentation is Factors Responsible for Online Resources Adoption in Indian SMEs, Way Towards Sustainable Growth. How online resources adoption can help SMEs in reaching sustainable growth. The authors for this paper, I myself is a presenter, PhD scholar at Aligarh Muslim University. Along with that, I'm also assistant professor at Bharati Vidyapeeth Institute of Management and Research, Navi Mumbai. And along with me, the co-authors, Dr. Asif Ali Sayyed, associate professor, Aligarh Muslim University, Dr. Anup Pandey, associate professor, Bharati Vidyapeeth Institute of Management Research, New Delhi. So today I'm presenting this paper. Let's move on to the first slide. So introduction, why we are studying about SMEs, why. Today we see the Indian economy is not doing very well. Overall, the world economies are not doing very well. So The reason behind it, we know from the last 1 year, okay, COVID-19 is affecting everything, production, sales, everything at the same time, the different organizations as well. What is the solution of it? What is the solution? If we just leave this 1 year, prior to that, was the economy doing good? No. So the solution is that we need to work on the backbone of the Indian economy. The backbone of the Indian economies are SME sector. Why this sector is the backbone of Indian economy? Because this sector is contributing around like 37.5%, 54% of our GDP. Out of that, 30% coming from manufacturing sector, 7%, 30% coming from service sector, 7% coming from manufacturing sector. So a big gap, and the government is eyeing in the next 5 years to make this 50%, this contribution to make it 50%. Currently, this sector, SME sector, is providing 11 crore jobs, and the government is eyeing 15 crore jobs. Currently, it is providing 45% of manufacturing output, 40% of total exports. The government is also looking for expansion in that also. With the limited resources and competition, can SMEs achieve that thing? Current scenario is this. Already you can see in the pie chart, after COVID, out of funds, 20% are completely out of funds, 20% of SMEs, 27% have a less than month fund. 1 to 3 of month of cash, only 24%. 3 to 6 month cash, only 23%. So only 94% SMEs are already facing cash crunch. 6% have more than 6 month cash. So what is the solution? Why we have chosen this topic? Because if we can advance our SMEs with the help of technology, if they will adopt technology, I guess it is the solution for them. They can grow, at the same time they can contribute more towards the economy, as this is the definition of SMEs as per government site. Government said in 2020 they have given a combined definition for SMEs in manufacturing as well as service sector. Prior, the segregation and classification was different. For manufacturing different, and your service sector is different. Currently, if the turnover is up to 5 crore, it is micro. Up to 50, then it is small. Otherwise, up to 250, then it is medium. So the objective of this study is to explore the factors responsible for e-commerce, e-resources adoption in SMEs. What type of e-resources? We talk about e-commerce channel, we talk about social media, or we talk about ICT tools. All three are in the category of e-resources. E-resources relate with the computer technology. We are not talking here about the M resources, mobile resources. And just a comment on the sustainable growth. The methodology of this entire paper is based on literature review. So now I'm straight away going to the Excel. As I was saying, that's why I was not moving the presentation in F5 mode. This is my study for this paper. I've taken the crux of these many papers. Like you can see the title of the paper, author, year, objective, research methodology, what they have followed. These are the previous paper which I have studied. The title is in 2017, and what they have, these are the variables the authors have taken, and then the findings. Social media has a positive impact on the firm in UK. This is limited to UK only. This study is limited to UK only. Then this study is about Twitter and how will Twitter affect positively in SMEs performance? Yes, it will. But again, the adoption factors are different in each and every study. Someone is talking about like this third study is talking about what are the factors for adoption: compatibility, cost effectiveness, trust, interactivity. Facebook usage will have positive effect on financial and non-financial. This is effect. But first four hypotheses talking about adoption. So our focus is on adoption. Another study, this is also descriptive research design questionnaire from 246 SMEs, and what factors they have considered: market access, customer relationship management, pricing, and innovation. These are the independent factors, and yes, it is impacting the ICT adoption in the average sales per month increase in the profit. Another study which is talking about survey research method, and the factors are firm innovativeness, firm size, these things affect the adoption of social media. Which type of e-resources they are talking about? Social media. Younger manager, if the manager is young, they are obviously they will look forward to adopt the e-resources, social media tools, because the older people are more resistant to change, what they have talked in this study. Genders will positively relate to adoption, but ultimately this factor comes up like this hypothesis was not supported. So gender does not make any impacts. Managers education, form geographical location and industrial sector. Then other studies, this talk about interactivity, cost effectiveness, compatibility. So in this manner, I have done a study of around more than 20-30 papers. TOE model. Now let's come back to my presentation. Next slide. TOE this complete Excel was not coming, so I just put a screenshot type. I've already shown you the complete Excel. What are the inputs from the literature review? If we talk about adoption of e-resources in Indian SMEs, it is really at very nascent stage. Mostly the studies are in foreign countries, and that too in the only in the previous 10 years only. In India, this is in very nascent stage. At the same time, only 4-5 contributions are there. And if we talk about the theories, which theories are supporting, no doubt every person will say TAM, technology acceptance model, or UT-AUT is currently going on in the air, and in the market. UT-AUT theory is very modern, and many people are writing paper based on the adoption based on UT-AUT. At the same time, there are other theories, diffusion of innovation theory, and the other theory is next theory is TOE, as I've shown you, technology, organizational, and environmental framework. And there are other theories as well, like theory of planned behavior. Now, what information I got from previous literature is that TAM and UT-AUT are good for studying the adoption at individual level. But here we are not interested in studying the adoption at individual level, because at individual level we know many of the individuals are using technology in India. Many CEOs are interested in using technology. Was the workers interested or not? We are studying at firm level. So if we want to study at firm level, then we need to think about the TOE framework, or we can think about DOE also. At the same time, we can also take insights from all the frameworks, the factors from all the frameworks. Some factors from TAM. There are certain factors which support firm level adoption. In TAM, there are certain factors in UT-AUT which support firm level. So we can give a combined model for e-resource adoption. That's what my approach in this paper. Methodology, it is based on literature review. Last 10 years articles I have reviewed, and different types of theories which I have reviewed in this paper, as I was discussing with you. These are the theories: TAM, UT-AUT, TOE, DOI. And the discussion of the paper, discussion part said that literature review helped in understanding different types of models adopted by researchers to study the adoption of different types of e-resources, electronic, first of all, e-resources. The e-resources can be categorized: electronic commerce, social media, cloud computing, ICT. And then the researchers can use, like, as I told you, TAM model, TOI, DOI, UT-AUT, at the same time, TRB theories. This is not TOI, this is TOE. And in the last 2 years, researchers are focusing more on UT-AUT and TOE. But if you want to take it individually, it will only give you individual factors. So in this paper, what we have find it out, we have make a combination of the factors from UT-AUT and TOE. Why we are still applying UT-AUT? Because recently a study has been done by Chatterjee and Kerr in 2019, and they have come, that is in Indian environment, on Indian SMEs. Their complete study was on UT-AUT. So we cannot ignore UT-AUT. We can take it, but along with that, we can take certain factors from TOE. So, and about comment on sustainable growth, will the adoption of technology will help in sustainable growth? I guess, in my opinion, yes, because it will reduce the overall costing of SMEs. The main problem of SMEs is costing is increasing. So overall costing will reduce. They will achieve economies of scale. There will be less wastage. At the same time, market expansion will be more. SMEs can go beyond global since the time of their inception, because they can use the social media tools to promote their products and services since the time of their inception. They do not need any physical office. From the virtual platform, they can expand themselves, increase in the skill and knowledge level of employees. Currently, very less number of employees are using these e-resources. So obviously there will be advancement of their skills and more employment and growth. So findings of my study is this proposed model which I have given on the basis of literature review, and this model has the adoption factors from TOE, from UTA-UT, and from TAM model, facilitating conditions, effort expectancy, relative advantage, compatibility, top management support, pressure from competitors, pressure from consumers, organization readiness, perceived usefulness, and perceived ease of use. These can be the factors. Like other researchers, what they can do in future, they can study the validity of these factors, because I have certain limitation. I was looking to write for this conference. We have limitation of page numbers and all. So I was not I didn't involve myself in validation of these factors. I've just proposed factors on the basis of my previous studies, and these are the references used in this study. 1 minute. So that's all from my side.
Thank you, sir. Thank you, sir. Pradeep sir, Pawan sir, if there is any questions, kindly.
Yeah. Anuj ji,
Yes,
can you show me your first slide?
1 minute. Stop the presentation. First is, this is ma'am.
Next to this.
Next is intro. Yes, ma'am.
Yeah, in this case, you have shown that 47% Indian startup and SME have less than 1 month of cash left.
Yes.
How did you collect this data?
And this data has been collected through internet resources. And this situation is of last 6 months during COVID time.
Is it reliable to have a data collection from the internet directly?
And no, this data is also in the research paper, those research paper which have been published in the Scopus.
That is also not reliable. Still, the situation is not over as far as the COVID is concerned. 47% data. Also, you are saying that the total contribution towards GDP is 37.54. This is for what? SMEs?
No, this is SMEs contribution.
Yeah. How did you calculate this contribution?
This contribution has been taken from the government generated report, MSME website, the annual report of Indian government. They are talking about this in their report, and they are also talking 11 crore jobs, and this data also 45% manufacturing, 40% of total exports.
Okay, this is from government sites.
Yes.
Okay, that can be reliable. But when we are going, you suggested some methodology to improve the performance in SMEs?
No, I am not suggesting the methodology. My objective is to study the adoption factors. What factors can be responsible for adoption of technology? So I was restricted to that only in this paper.
Is there any risk assessment also in your analysis?
No, not in this study.
Then how
challenges is another dimension. If we see the previous like 10-15 years of papers on adoption, they say 3 aspects. First aspect is adoption factors. Second aspect is impact of that adoption on the performance, and the third aspect is challenges. So we can have 3 different papers. One paper talk about adoption, another paper talk about performance, and the next paper can talk about the challenges. I know the challenges because when I was reviewing the literature, I've also noted down the challenges, but I haven't included in this paper because my focus was on factors only.
Okay. Okay, Gagan ma'am.
Okay, it's fine.
Pradeep sir, it's okay?
Yes,
Should
yes.
go ahead with next presentation? Okay, thank you, sir.
It's fine.
Okay.
Thank you. Can I leave?
Please go ahead. Please proceed.
Okay.
Miss Mandeepa, are you there for paper ID 68? Paper ID 68 is by Miss Mandeepa Roy and Mr. Ashok Mittal for compact slotted circularly polarized microstrip. So are you there, ma'am?
Yes, sir.
Okay. Are you going to present on your screen?
Yes, sir. Sir, my PPT is visible. Can you please check it?
Yes, ma'am. It is visible. You may go ahead.
Okay, sir. Good afternoon, everyone. My paper ID is 68 and title of my paper is Compact Slotted Circularly Polarized Microstrip Patch Antenna with Surface Wave Suppressed Characteristics for WLAN applications and characteristics. And I'm working with ABS-CC. Firstly, the problem introduction. Now, in the microstrip patch antenna, planar antennas, there is a severe problem of surface waves propagation. That those waves travel beneath the microstrip patch, this metallic patch. Beneath this patch, some of the waves get propagated through the dielectric substrate, and finally they get reflected from these edges of the antenna. So, whatever power it is being given as input to this antenna, that should be propagated as the radiation pattern through the top surface of this antenna, but some of the waves get propagated through the dielectric substrate and account for the power loss in the antenna. So my objective was to suppress these surface waves, and at the same time the antenna should produce circularly polarized radiation. So dual objectives I had to satisfy in this paper. So for that, after introduction, I will give you the literature review, whatever I have done from 2005 to 2017. Some of the papers were available for which the surface wave suppression in different terms were being given. Backlobe suppression. Yes, sir.
Sorry to interrupt. Can you enlarge this? Can you go for the PPT mode?
Yes, just a minute.
Okay, ma'am.
Thank you, sir. So from 2005 to 2017, so surface wave suppression, so there are some parameters for which if we improve that, the surface wave suppression will be there. So for that we can suppress the back lobe, improve the gain, radiation efficiency, then mutual coupling between patches can be reduced. So all these things were being considered, and what are the different techniques that were used for achieving this surface wave suppression characteristics that were also studied. So among the list given, basically there are 4 types of techniques for surface wave suppression. The first one is using the electromagnetic band gap structure EBG substrate, then reduced surface wave theorem, that is also being employed, then metamaterial superstrate, then holographic patch antenna, elevated patch symmetry. So all these things were incorporated. And after doing the literature review, I have come to the conclusion that EBG substrates are best suitable for the surface wave suppression, as the EBG substrates are easy to fabricate among all these different techniques, and these give the best result for gain enhancement. So I went for EBG substrate. The methodology used for this was, firstly, theoretically the antenna as per my frequency the antenna was designed. Then finite element model analysis was done using the simulation software, that is HFSS version 14. Then dispersion analysis was done theoretically. For dispersion analysis in my paper, the reflection coefficient for the antenna, the dielectric constant permittivity, and the surface impedance was calculated. Then parametric analysis of different parameters for which the EBG substrate is being designed, that was also done, and for maximum gain the parameters were optimized. Then after that, validation of the results was done again theoretically using surface wave theorem. Then measurement of experimental parameters, that was done in GB Pant Engineering College. So the fabricated prototype was measured, was experimentally, the parameters were measured. So this is the top view of the antenna first design, and in this the cylindrical metallic pins were inserted inside, they were through PTH print through hole technology, they were put inside the embedded inside the dielectric substrate at suitable locations, and side patches were introduced. And in the second part also, second design also, this was done, and some slotted antenna perturbations were also done on the top surface of the patch antenna, and coaxial feed was used. All the design parameters, all the values are given in my paper, what dimensions were being used. Parametric analysis for calculating the dimensions is also given in my paper, and theoretical analysis also given in my paper. And then due to slide restriction, I could not put all the things, but finally I've put the results in discussion here. In that, S11 return loss characteristics are being plotted for both the antennas, and for both the antennas, the experimental results and the simulated results are in good compliance, and at around 8.9 gigahertz and 9.2 gigahertz, the two different antennas are resonating. And the first antenna has the axial ratio bandwidth of around 200 megahertz, and the second one is having the axial ratio bandwidth of around 130 megahertz. And the values are given in my paper, and this is the axial ratio part. This one, this shows that both the antennas are circularly polarized, as it is being observed in this diagram only, that it is below 1 dB, so the values are in good compliance for axial for circular polarization. Then this is the final plot showing gain characteristics, and for both the antennas the gain enhancement was observed. For simple square patch antenna, we were getting very less gain of around 4 to 5 dB, and after using the surface wave suppressed geometry using the pins and side patches, the gain was enhanced to around 9 to 10 dB. So this is being shown for both the antennas in this diagram. The conclusions are that the circularly polarized antennas are designed for WLAN applications. Antenna is slotted for achieving compactness and producing circularly polarized radiation. And in two ways, I have done I have achieved the same objective using EBG substrate. Then theoretical and analysis, theoretical background that has also been there for validation of simulation and experimental results. Simulation was performed with HFSS version 14, and there was compliance in results that was being observed, and experimental measurement was done in laboratory in Delhi, GB Pant Engineering College, that was done. These are the references used in this paper. Thank you, sir.
Can we go for the questions? Pradeep, sir.
Ma'am, what is this HFSS V14? Can you please explore a little bit? You have used this for simulation.
Yes, sir. So this is by ANSYS, and the full abbreviated form is HFSS, and it is high frequency structure simulator. It is electromagnetic simulation platform. So for electromagnetic analysis of different planar antenna designs.
Yes. It's fine. Yes. It's fine. Thank you.
Thank you, sir.
Hello.
Yes, sir.
Pradeep, sir, any question?
No. Hand over to Pawan, sir.
Yes, Pawan, sir.
Yeah, please show me your first slide where you have shown your design.
Yes, sir. Yes, sir.
This is the structure of your antenna.
This is the top view. It is the substrate is FR4 epoxy, epsilon R 4.4, height 1.6 mm, and this is just the top view in which the copper portions are being shown.
Okay.
Yes, sir.
Okay, madam. Okay, madam. Your antenna is reconfigurable or having a fixed size?
Sir, this is not reconfigurable. I only had two objectives: surface wave suppression and circular polarization. So that was achieved.
Okay, madam.
Yes, sir.
If your antenna, suppose we want to make your antenna reconfigurable, is it possible? Is there any features we can include?
So for reconfigurability, generally we have the superstrate geometry, and by varying the height of superstrate, we can achieve reconfigurability.
Is
I have not
there,
used that.
is there any
Yes, sir,
possibility
possible.
in yours design?
Yes, sir. In this design also, this can be incorporated.
Okay, if it suppose I incorporate 4-pin reconfigurable design, where I have to insert these pins?
Sir, the pins are have to be embedded in the dielectric substrate, and for reconfigurability, generally the superstrate geometries are used. Superstrate geometry, one dielectric substrate on the top of this, and that dielectric substrate should have a metallic meta surface, patch surface. So in that case, it can be done by varying the thickness of that superstrate, and patch variation, it can be achieved. Frequency reconfigurability.
Okay, you are suggesting for a wideband or not?
Sir, it is around 200 megahertz. Sir, not a wideband, but yes, the antenna can be applied in wireless communication. 200 megahertz is also not bad.
Okay.
Generally beyond 500 megahertz, we term it as wideband. But this is again not a very much narrow band also, that 50 megahertz less than that, we call it as narrow band. So this is fine. 200 megahertz bandwidth is, sir.
Okay, madam. Thank you.
And thank you, sir.
Any other want to ask any question? Should we go ahead? Okay, thank you, Mandiba ma'am, for the presentation.
Thank you, sir.
I'm just calling paper ID number 73. I think Raman Kapoor is there for the presentation. Raman Kapoor sir. Hello. Yes, sir.
Yes, sir.
Raman Kapoor sir, are you going to present this paper?
Yes.
Okay, so you may go ahead. You may continue with the presentation, sir.
So, is it visible?
Yes, sir, it is visible.
Okay. It's a good afternoon all, and thanks for the opportunity to share this work. This was done by a couple of our students recently. So we are basically interfacing a sensor arrangement which measures the quality of air, and we're analyzing it by using a field programmable gate array. So that basically makes it a scalable package if possible in future. So these are the 4 authors. We are at the Department of ECE at ABS Engineering College. The paper ID is 73. So that's the layout of the content. So I think already there has been a few discussions about the air quality and why it needs to be improved. And before we basically can improve it, we first need to keep accurately monitor it, and that too in real time. So unless you can monitor it with reliability, then only you can move towards improving its quality. So here we have basically a reconfigurable system which keeps monitoring the air quality. And we have a field programmable gate array, which is basically an array of logic gates, a system of large number of logic gates, which is programmable by an electric field. And when we talk about electric field, we're basically talking about an applied DC voltage. So that voltage basically controls that gate array and allows you to keep configuring a system until you have basically completely optimized it. And we are showing right now, we are showing 2 different differentiations of air quality, but that can be modified by choosing different threshold level, because different regions will have different air quality. So the threshold level can also be defined. So the methodology is such that you have a sensor detector system, okay, which can detect particulates, traces of oxides of carbon and nitrogen, which can basically affect the air quality. And depending upon this constitution of the air, it can generate a certain electrical signal, okay, which is in analog form, and that is converted through the digital form using an ADC, which is basically an analog to digital converter, because our FPGA board can only take digital input and give digital output. So first we need to do this signal conditioning, So the analog output, which is an electrical signal, is digitized, sent as a stream of bits of zeros and ones to the FPGA board where our code is written. Okay, so we have 2 or 3 different codes written in Verilog, which are stored here, which are dumped onto this board. And then depending upon that board, the 7-segment display is driven, which basically tells you about the quality of the air. So because we are basically integrating this FPGA board, it actually allows us to reconfigure our system every time and then, because FPGA is simply a soft implementation. Okay, so this is something where you can change your logic by a code and you can optimize your system. So sensor's analog output is first processed here and then converted to a digitized signal sent to FPGA board, and then it is driven. So we have basically monitored air quality at different positions. This is not a data taken from literature. This is actually been optimized data which we have observed. So like at different places, we have measured the air quality and then taken the output from the sensor network. So this value which you see on the right is basically a voltage in millivolts, depending upon the quality of air. It has been taken at different places during high pollution times and immediately after a rainfall when pollution level goes down. So you can see that there can be this kind of threshold. Basically you can decide. Say if you take moderate as your threshold, so anything above moderate is okay, anything below moderate is not okay, then you are looking at something like 100 to 200 millivolt of output from the sensor network. Now here is the thing is that you can have a network of sensors, so you can also have a different value here. That's why I said in the introduction that the threshold can also be modified. So this threshold is then digitized and sent to the FPGA board. There's a small modification required because the FPGA board is a high frequency board. It has a frequency of 100 megahertz. So you're looking at about a time period of 10 to the power minus 8 seconds, which is actually very fast for human observation. So we have also coded a frequency division circuit inside, which is dumped inside the FPGA, so that whatever data is going, it comes out a bit slow, so that it's readable by humans. So we have one set of code which basically works on this table. Then we have another set of code which basically does the frequency division, and then there's a third set of code which actually drives the 7-segment. And here you can see that all this thing, this is your sensor network basically, and there's a small circuitry here, and this is the FPGA board. So right now we have 2 levels of distinction based on the moderate value. So whenever our voltage levels based on air quality goes below moderate or remains above moderate, we display a good air quality reading. And whenever it goes below, we display a bad air quality rating. Okay, so right now for this work, the threshold is this, the moderate level, 100 to 200 millivolt output from the sensor. Now you can have a network of sensors that is going to change your threshold depending upon the location. So just to summarize, we are basically providing a simple system, but it's yet quite effective. It requires 3 sets of codes which we have written in Verilog for frequency division interface with 7 segments, selection of what you are actually going to show based on your air quality. As we are using FPGA, it is reconfigurable, and because it is all CMOS based, it is also scalable. There's already fabrication facilities for CMOS circuits. So these kind of things are scalable also. And because air quality doesn't change at very small distances, so an FPGA board can basically, this whole system, embedded system actually can be used to support a certain region or area. And it supports integration with each other. So the sensor is integrated with Arduino. Arduino, being a digital system, is integrated with FPGA. FPGA can be integrated with 7-segment. And overall, it's all digital, so it consumes very less power. So So going forward, I think our next aim is to basically modify our code to take these things also into account. So rather than having a threshold at moderate, if we can say modify our code to these small steps of voltages, okay, so that we can also display hazardous air quality or good air quality if we manage to get that. And these are our references. So most of the references are basically related to the integration aspect of the project. And that's about it. Thank you.
Hello, Raman.
Yes, yes, sir.
You are faculty in ABS or student?
Yes, so I am a faculty. This work is done by 2 of our students.
Of your student. What type of sensor did you use in your project?
We used MQ135 sensor, which is a high resolution sensor for particulate matter and other chemical which are generally found in air, like oxides of NO or CO and some other materials. So it has this voltage is basically proportional to those chemical composition.
This is a voltage sensor.
No, sir. It's basically a air sensor or a chemical sensor which produces voltage as output. So it has a transducer inside it, which converts that to an analog voltage.
Do you know what kind of reaction takes place when the quality goes down?
You mean the air quality?
Yeah.
Yes, sir. It actually has a resistive network inside it. So that chemical reaction actually alters the resistance, and because resistance is directly related to voltage, so there's a network of resistances inside. So that chemical reaction basically alters the resistance of it inside the MQ135. We have gone through the complete data sheet of it, and this calibration was done by the students themselves.
This is the chemical reaction which decides the generation of voltage level and hence the quality of air.
Yes.
It is not the resistance happening within the two.
That's actually inside happening. Because resistance and voltage are directly proportional, basically. So, but if you get resistance out as an output, that is not very useful to be to integrate with another embedded system. Voltages are easier to, or they are better to handle, basically.
Yeah, that's okay. We can easily manage the voltage signal, resistance instead of signal. But my question is, when we are going to analyze the quality, you are having a 2 electrode or you are having an electrolytic solution so that you can decide that what should be the quality of air is depending upon your output, whatever maybe the signal you have been generated as a voltage, current or resistance.
See, that's why I said that the threshold is something like in metro cities, this is going to be a different value, and if you go uphill, this value is going to be different. So basically, you have to, instead of going inside that chemical reaction, you have to rely on the output of the sensor. Then you can design your embedded system. So the same sensor will produce different voltages in a pure environment, and it will produce a different voltage in a highly polluted environment. So instead of going on the reaction, we basically have to rely on the output of the sensor, basically.
Okay, I think you are more concerned about the interfacing of that sensor with your system, and so that you can, not on the working of the particular sensor only. Okay.
Yeah, you can say that.
Yeah. Okay, I can understand. Who is hosting the session now?
Any more question, Dr. Pradeep and Dr. Pawar?
Yeah. From my side, okay, madam. You can go ahead. How many candidates have been left yet?
Sir, only one, I think so right now. If anyone is left, they can raise their hand, or they can contact Navendra Pratap Singh regarding it. Our last paper, according to me, is paper ID number 78. The author of the paper is Rahul Virmani, Hemant Ahuja, sir, Gurpreet Singh, and Arika Ahuja. The name of paper is Load Frequency Control in Hybrid System Considering Intermittency Due to Renewable Penetration. Okay, 74 is also present. Gulshan sir is also there. So, two papers will be presented, sir. So, Virmani sir, are you there?
Yes, ma'am. Good evening. I am here.
Okay, Virmani sir.
Ma'am, with your permission, may I start?
Yes, sir. Yes, sir. Definitely.
Okay. Thanks a lot. Sir, this is is the screen visible?
Yes.
Hello.
Yes,
the
sir.
screen
It is visible.
Yes.
Virmani sir,
Okay. First of all, I would like to thank the organizers of this conference for providing me an opportunity to present my work done here. So the authors of this paper entitled Load Frequency Control in a Hybrid System Considering Intermittencies Due to the Renewable Penetration is Ms. Harika Singh, myself, Rahul Virmani, Dr. Hemant Ahuja, and Gurpreet Singh. We are associated, Ms. Harika Singh is associated with Kite Group of Institution Ghaziabad, and the rest authors are associated with the ABS Engineering College Ghaziabad. Now, as we all know, the reduction of CO2 emissions for the prevention of global warming has become a worldwide issue, and large scale penetration of renewable energy is planned to be integrated into the electric power system. Now, as we are integrating the wind power generation of photovoltaic PV, which is most common nowadays, the output fluctuates with the weather conditions. These fluctuations, in some technical terms, have been named as intermittencies. Also, now there have been such impact on the power system such that these new technologies such as wind and PVs lower the inertia of the entire system. And earlier, which was automatic generation control theory, which is commonly known as AGC, has not been basically in the similar manner efficient for these renewably penetrated power system, or in this case, I will be dealing a small isolated power system. Now, if I go with the what is load frequency control is, now as we all know, when in the power system, the frequency of the output should always be remain constant, as well as it should act as a constant power source and a constant voltage source for us. Now, the aim of LFC is mentioned in three parts. It is to monitor the variation of active power by providing the signals for control of the frequency regulator. The second objective is to control the active power output of different generating units within the limit in the prescribed control area in the response to the changes in system frequency and tie line loading. The tie line is nothing, it is the interconnection between the multiple areas. Now it also helps to maintain the scheduled system frequency and establish the interchange within the other areas. Now, this is my proposed system. The proposed system, what I have used a thermal power system. Now, for the thermal power system, and I use an aqua electrolyzer, which is taking the power from the bus and feeding it to the fuel cell, which in return is again returning the power to the bus. I have also put a wind power as well there as well. I have put a PV system as there as well. I have put a battery energy storage system as there as well. Now, battery energy storage system is basically a double-sided, because when discharged, it will take the energy from the bus, and when fully charged, it will give the energy to the bus. Now, as per the literature survey, these constraints have been determined from the research paper, and a single area network has been found. Now, when I am talking about a single area network, I will not take it as a single area network. I will be taking it as basically a microgrid, because the governor and the turbine, which has been modeled basically for a bagasse power plant or a sugarcane waste power plant for this thing. Now, basically when we are talking about the conventional controllers for the controller which has been inscribed here, the basic controller which is commonly used in the literature while AGC was PI controller. Now, the steps which were used for putting a PI controller in the process was to determine the open loop step response and determine what's to be improved. Now, if there was a rise time was slow, or we need to improve the rise time, a proportional controller was added. If we need to improve the overshoot, that means get it near to zero, a derivative control was added, an integral control was used to eliminate the steady state error. Now these all three variables have been adjusted until have to be adjusted until we obtain the desired response. Now I have simulated the entire system. This entire system has been simulated on MATLAB, and the controller used was PID controller. Now for the step change in the load, which has to be given by this delta PL, the step change in the load, the controlled output, if you see this, it has the frequency fluctuation has settled to zero. And by using this Kp, Ki, and Kd. Now the gains have been adjusted in this PID tuning by Ziegler-Nicholas method in MATLAB, and then fine-tuned basically MATLAB tuner app to get the desired. Now in the latest techniques, I have used a fuzzy-tuned fractional order PID controller. Now you can see there have been a lot of changes in the system, although the fuzzy control, the efficacy of the fuzzy controller depends upon the rule set design. And the set I don't think so that they were properly optimized for the fractional order. So the response was not as much satisfactory as what I required from it. But there was still a reduction in the settling time, a peak overshoot, a peak undershoot, and definitely the steady state error was also zero. Now, this fuzzy controlled fractional order PID controller, it is better if the better membership functions are and the input functions and the output functions are mapped. Now, this process can also be used by using many intelligence techniques such as PSO or other PSO or ant colony optimization theorem or bacterial foraging optimization theorem. Now but I used a fuzzy because of the intermittencies obtained in the wind and the PV cell. Now, when the system is getting a lot of changes in the input itself, it is always better to go with the fuzzy FITE system as per the literature survey. Now, if we go with the conclusion, the renewable penetration has increased the frequency deviation as it has reduced the inertia, increased the fluctuation due to the variable nature of source. The AGC used in the last system can't be used for the same due to techno-economic reasons. So the intelligent adaptive techniques must be applied to the MGs as well as for the stability issues. These are my references. Thank you.
Thank you, Rahul sir. Any questions, Dr. Pawan, Dr. Pradeep?
Yes. Sir, there is one question at my end.
Yes, sir.
How this PID controller works, sir?
Sir, I have already told this PID controller when the error is there. Now, if there is a response which I do have a very high rise time. Now, if you want to steepen the rise time, you will add up a KP. That's a proportional controller. It's basically a gain if you could talk in the terms of electronic circuit. Now, if you want to improve the overshoot, sometimes you will need to have a you need to settle your response at say zero in my case. Now, but it is having an overshoot. So what you will do is you will do the derivative controller. And when you're talking in the terms of suppose now the system is settling down at other position rather than the zero, and you want to settle the system exactly at zero or as much close to the zero, which is in my case, you will definitely add an integral control.
Okay. Suppose if there is a case, if you want to suppose in case of heat and mass transfer laboratory, okay, if you want to settle down the value of temperature, okay, because you want to make that system, okay, to come in steady state condition. So for that steady state condition, the variation in the temperature should be stable. Okay. So in that context, I want to know how this PID controller will work.
Sir, whether you want the system to be stable for a large time or for the smaller time, because the analysis which I have done is for
once you have started your apparatus, okay. So you will observe that after a certain time interval, okay, the variation in the value of temperature will become stable.
Yes, sir, definitely.
So in that context, I want to know how this PID controller will work.
Sir, suppose you want to have a temperature range of around 50 degrees Celsius immediately, but what your heater element is doing, it is increasing the temperature at a very slow rate. Now at that time you will definitely need a gain to get to the 50 degrees Celsius very fast, and that is what I can interpret with the rise time. Now suppose the temperature is moving. Now the heater element is so heated so high that the temperature goes beyond 50 degrees Celsius. That's an overshoot. So then that case you need to add a derivative control. Now at the settling state, suppose the ideal temperature, the set point of the temperature is 50 degrees Celsius, but it is settling as 48 or 52. Then at that time you will use a derivative control. Now these gains for these controllers have to be optimally tuned by some algorithm or some logic. That the initial was hit and trial, in which you definitely put some values for the KP, KI, and KD, and then see whether the response is close to that. But nowadays, since there are a lot of tuner apps available on the MATLAB as well, so you can definitely tune them. Or better, you can use a intelligent control technique such as fuzzy system, ANN systems, or any kind of optimization algo as well in this thing.
Okay. Thanks, Rahul Virmani ji. Thanks a lot.
Thank you, sir. Thank you, sir.
Hello, Rahul.
Yes, Pawan sir. Good evening, sir.
Good evening. Can you tell me how did you decide the time constant for power system, generator, your turbine system, as well as for the governor system?
This is actually if you talk about the how did I decide? Actually, I didn't decide. This is a problem given. This is a problem given in Algard. This is a problem given in Algard for the power system. These three. Just give me a second, sir.
That value may be suitable for particular type of system.
No, these three values have been these. That is what I'm trying to say. When we were going for the generator and for the power system, these three values have been taken from Algard, and these three have been taken from the literature survey, depending upon the ratings of the system. So these value of the electroequivalent time constant for the electrolyzer, for the fuel cell, these systems have been modeled up and then brought to a first order system, and then these values have been brought.
Why the time constant of power system is much more than the turbine time constant?
So why the turbine? So I couldn't understand that.
Why the time constant of power system is much more than turbine's time constant?
Okay, you are saying that why TP is much higher than TT?
TT1.
Okay, TT1. Why TP is much higher than TP1? Sir, in this case, the power system is basically comprising of the loads. But I have modeled, the Algard has shown that if you model the entire system in the linear form, that entire system, when you model it once again, it is 1 upon MS plus HS plus GS. Now, in that case, the inertia of the entire power system is very high. And we are not talking only in the terms of, the mechanical inertia. We also have to take the concept of the electrical inertia as well. That is why the time constant is very high.
ठीक है. Okay, Rahul.
Thank you, sir.
Thank you, sir. Any more questions from other participants? Okay, then now next presentation is by paper ID number 33.
For Shailendra Visaria, sir. Now I'll try to run the video.
Okay, sir.
If it is not audible, kindly tell me about it.
Okay, sir. It's paper index 33, Shailendra Bisaria, sir, Preeti Anand and Rishabh Agarwal. And the title is Multifunction Filter Using Current Conveyor, a Survey.
Is this video visible to you?
Yes, sir, it is visible.
Okay, I'm just, switch it on.
The paper ID 033.
Is it audible?
Topic basically is multifunction filter.
It is audible. It is not actually visible. Audio is playing but not visible. Is it audio only or both?
It's audio, video. Both are there. But whenever I start playing, the video is playing in front of me. Though I am sharing with you also. Yes, sir.
Like desktop,
I'm
shared
doing
desktop.
okay. I'm doing two things. One thing I'm including computer sound. Okay, that is for the video. And second thing, now I am screening that I'm just sharing desktop. Okay,
Yes, yes, desktop.
okay, maybe that's why.
Now it is visible, sir.
Okay.
The paper ID 033. The topic basically is multifunction filter using current conveyor, and this is basically a review paper based on different multifunction filter implemented using current conveyor. First of all, the abstract. This paper presents a survey on multifunction filter using current conveyor, and we have compared various research papers based on different parameters like power consumption, frequency, supply voltage at which they operate, CMOS technology used, and the type of current conveyor, etc. We have taken the technology used. As per the papers, the latest technology used is generally 180 nanometer, or in few papers we have taken.
Navin sir, I think there is some issue because voice is not audible.
Naveen sir, please unmute yourself, please.
The same current.
Yes, ma'am.
This current will be
I'm just stopping it.
This was the initial.
Is it audible now?
Later on, it was modified.
Yes, yes.
In CCI 2, the second generation current conveyor, we what changed was there that input terminal was increased as far as its impedance is concerned. So for that, I input current made to 0. So only the voltage reflected to the another terminal, while due to this voltage, the current produced at the another terminal was reflected to the output terminal. In the third generation, basically, the direction of current at the input terminal was reversed. So these were the current conveyors, and this is basically that element which we have taken based on which multifunction filter has been generated. Okay, so this the diagram is just showing one simple CMOS implementation of CCI2. Okay, as I already said, the input voltage applied will be reflected at the another input terminal X, and the current due to this generated will be mirrored at the output terminal. Okay, so this is the basic implementation approach of current conveyor. Now, current conveyor is used to implement the multifunction filter. Okay, and we have, as I have already said, that we have taken different multifunction filter implementation approaches using current conveyor. So this is the first approach as shown you proposed by Dr. Jagla and others. Dual output CCI bipolar implementation with the same approach, that means X reflected here and that current is reflected here and at this terminal. Okay, here the author has proposed this approach, that how basically multifunction filter can be implemented using this CCI. Okay, and as we can say that what basically we are want to obtain in multifunction filter is basically all the functionality, that means low pass, high pass, band reject, all filters should be implemented. So this is the approach which the researcher has taken. Then proceeding further to the next approach, that is differential difference current conveyor. Differential difference current conveyor basically has the modification that here you can see that in here at the input side, y1, y2 and y3 terminals are taken, right? And the output is same in the same manner, that means x and then passes to z. But the inputs are y1, y2, y3, and as the name indicating differential difference, that means difference y1, y2, and y3. As per the polarity, the difference or addition may be done of the three, and hence it can be used as adder subtractor of different inputs, and then it can perform the filter operation of the same. So this has the beauty that it can perform this additional operation. Okay, in multifunction filter. Then next approach was low power, low voltage multifunction CCI. Here the modification done was basically that if you see it carefully, that bulk terminal is connected such that basically the bulk potential is increased. So if VSB is changed, basically that will change the threshold voltage of the device, that is the MOSFET. So by changing the threshold voltage of the MOSFET, basically power dissipation is decreased. So if power dissipation is decreased, that we can say is the requirement of the present is that anyhow power dissipation is should be decreased. But changing the bulk potential also creates some more problems, like the device cannot be used for higher voltages and for high frequency. So however, this filter is good as far as low power operation is concerned at a lower voltage, but is restricted for high frequency application, right? However, obviously multifunction filter is implemented using this approach, and we can implement definitely the all the operations, that is low pass, high pass, etc., right, to some limit. Another approach used was multiple output CCI, which has nothing new, only some more terminals were introduced, and the implementation was done using the same approach as was proposed in one. Right. Similarly, there are other different papers which we have taken into consideration, and here we are presenting only the main papers, which we have seen that there is something new. At last, I want to show you this one implementation, which is good in comparison to others. What here has been done, if you see, this is same, right? Only one extra X terminal is used. That is why its name is EXCCI. Extra X terminal is there. And only Z1 and Z2, two Z terminals are taken. So basically, author has beautifully modified the structure of basic current conveyor and implemented the multifunction filter, that means the universal filter, which is named as TSO, that is 3 input single output. What he has done is that he has taken 3 input current, I0, I1 and I2, right? And I output obtained, if you see this expression, that is just by changing the value of these 3 input terminals, that the 3 input current, that is I1, I2 and I3, we can easily modify this expression to give the response of either band pass filter, band reject filter, all pass filter, low pass filter or high pass filter. Anything can be easily done just by changing the value of these 3 currents. Okay, so this is having the beauty that only single one CCI is used to implement the same, and less number of components are used to implement all the functions, right? So before concluding, I just want to show you the comparative analysis of various research papers. If we see the power consumption, as proposed in these reference papers, you can see that the least power consumption is 1.45 microwatt in this reference 5, right? Even less than the power consumption proposed by this 4.8 using bulk approach modification, right, of bulk. So finally, and this is XCCI only, right? No more CCIs are used. However, you can see that the technology is 250 nanometer, while in all other paper technology is 180 nanometer, right? So what we have concluded is that by observing the various research papers, we analyze that paper 5 is better than other works because it reduces total number of transistors, so area reduces, right? And the power dissipation reduces, as well as the complexity is also reduced, obviously, right? And what we want to propose from our side is that further we can realize this filter using 180 nanometer instead of 250 nanometer. We can realize this filter using 180 nanometer. This is the future work which we can do, right, using this approach. So this is these are the references which we have taken. These are all the references which are there with who have implemented multifunction filter using current conveyor. Okay, and based on these, this survey has been done. So this is all about the presentation. Thank you.
Thank you, Shailen sir. Shailen sir is there. Any question from Pradeep sir and Pawan sir?
Yeah.
No, ma'am, it's fine at my end.
Okay.
Yeah, Devendra ji.
Yes, sir.
Can you show me your slide before your conclusion?
Okay, just let me play the let me show the PPTs now. Okay, just a minute.
Gagan man, this is the last presentation.
No, only one paper is left, sir. Sorry if it's taking time, but only one paper is left.
Don't worry, ma'am. I will not take much time.
So, Gulshan sir is there or Rajneesh sir is there?
I'm Gulshan using Rajneesh MS login because my login is creating problem.
Okay. I was thinking that Gulshan is not there. That's why I was asking. Okay, Gulshan. Not an issue.
Do you want to see? Is this PPT visible to you?
No, sir. NP sir, it is not opening.
Okay.
Same issue, I think so.
Okay, left it. Let me ask verbally. You have mentioned in the parameters, and one of the parameters is CMOS technology. Hello.
Yes, sir.
Yes, one of the parameter is CMOS technology. You have shown the slide, that one. Not the very first. It was before conclusion. You are considering parameters, power consumption, frequency, voltage, like that. How the CMOS technology is a parameter?
Sir, this is the parameter taken into consideration the VLSI design point of view, as we are talking about the chip manufacturing process. So, technology is basically taken into consideration that at which technology the filter has been designed. At present, we are working at 10 nanometer technology in industry. And all the research paper which are there, they have used a maximum of 180 nanometer technology. They are far behind from the present industrial use. So actually the ultimate aim is to design a latest multifunction filter, and that work has also been done by my students, and they are presenting that paper also in they will present that very soon. The result has we have also derived the result for the latest technology also. This is the purpose basically.
Means you are stating here that in reference 1, the CMOS technology used, it was including 180 nanometers.
Yes, sir.
Whereas in the reference fifth, the technology involved 250 nanometers.
Yes, sir. Sir, that's what I am saying, that in all the research papers which are there at present, the technology used is minimum technology used is 180 nanometer. Otherwise, it is 250 nanometer, 350 nanometer, 500 nanometer, or more than that. And if we see the industry demand, the technology should be much less than that. In all the institutions, like in our institution, we are having up to 45 nanometer where we can design up to that level, and that is highly required. That is why we have taken all the technology which are presently there in all the research papers, and then we have tried, we have given that message also in this paper also, that people should try to design it at a lesser technology level.
Okay. Okay, thank you.
Okay, sir. Thank you, sir.
Any questions, sir? Any more questions? Hello, Dr. Pawan, Dr. Pradeep.
Yeah, ma'am. This is okay.
Any
for my
question,
side.
or we should proceed now?
Yes. Please go ahead.
Next presentation is by paper index number 74, Gulshan Dubey. The title of the paper is H Infinity Robust Control Approach for Quarter Car Suspension System. Gulshan, sir?
Yes, ma'am.
You can present your PPT.
Okay, ma'am. Is PPT visible?
Yes, Gulshan, sir, it is visible.
Okay, shall I start?
Yes, sir.
Okay. Welcome all, and thank you for giving opportunity to present my work in this conference. My research topic is H infinity control, which is basically a robust control approach. And the model I chosen is quarter car suspension system. Myself, Gulshan Kumar, an assistant professor in electrical department of ABS Engineering College, Ghaziabad. So I have chosen the quarter car suspension system because the vibration is a topic which is majorly concerned in mechanical and electrical. Be it equipment, machine, or anything, vibration can cause damage to the machine. And also, if I talking about the suspension system, it can give discomfort to the driver. So which is basically a physical damage to the driver. So to provide a comfort to the driver, there should be a proper suspension system. So suspension system designing is not an area of mechanical system, but it can be used in control system area also. So here in this slide, you can see the picture of quarter car suspension system, which it is a tire stiffness, wheel mass, and this is a car body mass and spring. Basically, car suspension system is a combination of spring, damper, and force. So if you are not including the controller, then it is called as a passive suspension system. If you are using a controller, then you can call it as an active suspension system. So if I talk about the mathematical modeling of this system, then we can say that the system is multi-input and multi-output system. It provides many.
Only single slide is visible to me.
Sir, I'm talking on this slide only.
Okay.
Okay, so when I'm talking about the mathematical modeling, then it shows that the system is multi-input, multi-output. That in figure you can say that the one input is force and one input is road disturbance. So to control the vibration of this mass body, this car body mass suspension.
Yeah, excuse me.
I'm using
only your title slide is visible to me.
Okay. Is it visible now?
No, not yet.
No, it's not moving ahead.
Is it visual?
Yes, yes.
Now it is.
So This is the picture of Kottaka suspension model. So in this picture, you can see that this KT is the tire stiffness, this MU is the mass of wheel, and this is car body mass. And basically, Kottaka suspension system is a mass spring damper system. So if we are using a controller, then it is called as a active suspension system. If you are not using a controller, then it is a passive suspension system. And passive suspension system cause more take more time to get settles. So if I'm talking about the mathematical modeling, then it also says that the system is multi-input, multi-output system. Here you can already see that the input for the system is control force and the road disturbance. So to control this system, I'm using one transfer function, one mathematical transfer function is output because of road disturbance. So this is the transformation of my Kottaka suspension system and caused by road disturbance to control the vibration caused by road disturbance. So the control theory I'm using to control this system is H infinity. Basically, H infinity use the weighted system, weighted output of that error. That Y is the error, and this Z2 is the weighted value of output. So if I'm talking about the mathematical equivalent equations, then Z1 is the error weighted error, Z2 is the weighted output, Y is the actual error. So this W1 and W2 is the main weighted function to be designed or to be selected as a to achieve a desired output. Okay, and to propose my system, I'm relating this W1 and W2 to the S, that is the sensitivity of the system, and T, that is the complementary sensitivity of the system. I compared these two parameters, two terms, sensitivity and weighted functions. So out of many research papers, I included these three literature review in one that is saying that the passive system takes more time, and for designing the controller, it is not only the concept of mechanics but also a control system area, and the selecting the proper weight function is the also a critical process. So this is the methodology I used. Here I relate the weight function 1 and the sensitivity of the system, which should not be increased, should not be more than the 1, because basically the idea behind this equivalent is to control the worst case scenario. If we are controlling the sensitivity of the system, then it is not changing, the output of the system is not changing according the variations. And that is the robust control. That is the main aim of the robust control, to neglect the variation in either parameters or inputs. So for this simulation, I used a system design parameters like maximum overshoot up to 30% and settling time less than 2%. So on the left side, you can see that the conventional method and the desired algorithm. So according to my proposed algorithm, I can achieve a less settling time as compared to the conventional method. And if I am talking about the variation with respect to the parameters like spring constants or mass of the system, so this also the response of the system, overall system is getting within the range. It is not getting out of the range. So we can say that the H infinity is a robust control for the system. So these are more references for the paper work. Thank you.
Any question, Dr. Pawan, Dr. Pradeep, from your end?
Can we consider adaptive controller as an adaptive controller?
Yes, sir. Adaptive, if you can use it combined with the another method, obviously it can be combined with another adaptive or model predictive methods, then you can say that H infinity is the adaptive method.
What are the silent features of H control infinity controller?
Station details.
What are the silent features of
H infinity controller?
I'm saying that the maximum of sensitivity of that value should be under the 1, should be 0 to 1. So this feature can be used as a designing the weight functions.
Hey, what do you mean by W1, W2?
W1, W2 are the weighted values for the error and the output.
Yeah, these are the weightage.
Weighted value of the error and the output. This is the error between feedback and the reference point. So
Yeah.
Z1 is the weighted value.
Z2 is W2 into PU.
Z2 is the output, overall output of the system. Suppose that is the output. Here you can get the output. So Z2 is the weighted multiply the output, overall output.
Okay.
This P is the system and this K is the controller. So with the use of W1 and W2, we can design the controller.
It means Z1 is equal to W1 into Y.
Z1 is equal to W1 into Y. Yes, sir.
Okay. 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 Thank you.
Okay, sir.
Thank you. Thank you,
Can we
Gulshan
leave
sir.
now?
Thank you, Pradeep sir and Pavan sir.
Thank you, ma'am.
Sir, any more paper is left or not? We can conclude our event now.
No, ma'am, no paper which is registered is left now. We can conclude it.
Okay, sir. Sir, first of all, I would like to thank Dr. Pavan and Dr. Pradeep for giving their precious time for this event. And I would also like to thank all the participants which are present over here for enriching our knowledge with their valuable research. I hope this type of conferences will be held in future, and we look forward to see Dr. Pradeep and Dr. Pavan for such type of event. Thank you, sir. Thank you very much for being here and being a patient listener, and definitely giving proper feedback to every participants. Thank you, sir. Thank you very much.
Thank you.
I think all can leave now.
Thank you. Thank you, ma'am. Gaganpreet, ma'am. Thanks a lot.
Thank you, sir.
For providing such a wonderful opportunity to me to share my views on research papers related to different areas. And I also want to convey my thanks to the organizer of this international conference, Futuristic Innovations in Technology and Engineering 2020, FITE-2020. So I'm very much thankful, to all of you. And I also want to say thanks to Dr. Pavan Kumar sir, and all the participants. Thanks a lot, Pavan sir, also.
Okay, I think it was a very nice event, and we can leave now. Thank you all
for
being here. Thank you.
Thank you.